So hello everyone, welcome back. So what is today's an agenda as part of? Okay, this is the agenda, right? Today, let's get started to kick things off. The items that are part of these items, right? That are part of the agenda. To start with, will help you to understand what is DAX and why a DAX is required. Why do you have to use DAX? And first of all, what is DAX is all about? What does it stands for? DAX stands for Data Analytics Expression. Data Analytics Expression. And then we will move on with understanding the X velocity. Earlier, it was called as Vertipack engine. And then we will understand the mechanics of how the X velocity engine works behind the scene. And followed by this, we will continue with explore the operators and data types that are available in DAX. Next, if time permits, we will jump into aggregation functions. I think we will have time to cover aggregation functions. Rest of them, we will see how it goes, okay? So what is DAX? DAX is a combination of functions, operators, constants. It's a mix of all these three, okay? That is used in your formula, okay? DAX is not only used in Power BI, it is used in Excel, Power Pivot. I don't know how many of you have used Power Pivot. Satya, I guess you have used Power Pivot. Am I correct? Okay, and SQL Server Analysis Services, a tabular edition, and Azure Analysis Services, and also DAX can only be used to filter or query a physical table. We use so DAX is nothing but built-in functions. That's all, okay. And also, as part of the if you want to use these built-in functions and to define any business logic or something, obviously you need to have the combination of operators and constants along with your function, right? Without that, you cannot implement your business logic. Okay, now the question is, what kind of functions are available? Built-in functions. A lot of functions are available. Like I discussed in the past, I don't know. So yeah, for this batch, you're not aware, but the previous batch member also are available as part of this batch. We discussed about sum function. Sum is very common. Even in the Excel, we use sum function. That is the most commonly used function. The sum function, average function, minimum function, min function, max function, right? Those kind of functions are available here. And also we have much advanced functions are also available here. Now the question is, okay, fine, we have some function is available and the minimum function, max function, everything is available. So why exactly we need to use DAX? For example, if I wanted to compute the sales amount, if I multiply the price and the quantity in the order transaction file, if I take a product of these two columns, quantity and price, I can get the sales amount. Why do I need a DAX? The important advantage of DAX is you can reuse the DAX formula in multiple places. Supposing in your report, for example, you have various visuals are there here, right? Once you create the measure or calculated column, you can use it across all these visuals. The number one advantage of creating the DAX or defining a DAX is reusability purpose. You can reuse it wherever it is required, okay? And also, if you want to create a complex or customized formulas, where a simple sum or average may not be sufficient. In that kind of situation, you need DAX function. So not all the time we use average minimum alone, right? Sometimes we will be doing our business logic will be very, very complex. We want to filter the data based on some condition or more than one condition. And then we wanted to do some kind of average or sum, right? The straightforward sum and average alone will not be helpful. Right? So in that case, the DAX is very much helpful. So the number one advantage is once you create a DAX query, they call it a DAX query also or DAX formula, you can reuse it. Okay, you can reuse it across the visuals, across the pages in a report file. And also, if you want to perform, or if you want to perform advanced analytics by implementing or defining complex logic, that kind of situation, the DAX is very much helpful. And with the DAX, you can get most out of your data in order to solve business problem efficiently. You can perform advanced analytics with the DAX. Okay, and the next one is this is the simple DAX query. This is a measure. This is called measure. So here on the left side of the equal sign, you can see the total sales, and this is nothing but the measure. This is called your measure, or it can be your calculated column. Okay, and on the what is the equal sign? It indicates the start of the formula. So followed by the equal sign, you have a DAX function sum. Okay, and then followed by the sum, you have the opening parenthesis and then the closed parenthesis. So whenever you use any function like sum, average, min, max, you need to use the parenthesis. Followed by this, you need to use open and closed parenthesis. Inside the parenthesis, you'll have to specify your column name or table name or so. Okay. So this is how you can define the measure. Okay. So where are DAX formulas used in Power BI? The calculated tables, and you have the calculated columns and measures. What is calculated tables? So the calculation, suppose you want to create the date dimension. You remember we have created the table, right? You want to create an table, additional table, and add in apart from or aside from the business tables like fact sales, customer dimension, location dimension, and the product dimension, category dimension. Apart from this, if you want to have the date dimension, right, you can, in that case, you can go ahead with creating the calculated table. Okay, the calculated table, that this is the classic example. And other one is the calculated columns. So if you want to create any additional column with your existing table based on some formula, in that kind of situation, we can go for calculated columns. Already in your table, you have 10 columns, or there in addition to that, you need to have 3 or 4 more columns you need it. In that kind of situation, you can go for calculated columns. And the next one is the measures. If you want to perform any aggregation, or if you want to add a summary to a table, or if you want to perform any aggregation, in that kind of situation, we go for measures. What do you mean by measures? Sum of sales, average sales. In this case, we use some formulas like a quantity into price. Okay, and the sales revenue minus the sales, the cost of goods sold. So, and if you subtract them, you will get the profitability. If you want to create a new columns based on the existing column or based on some business logic like sales minus cost, that is your profit. So in that kind of situation, we go for calculated columns. But each type has its own advantages and disadvantages, especially when you create multiple calculated columns in your existing table, especially if the volume of the table is very high, and it will consume a lot of storage in the memory. Okay, and the other aspect of this is, yeah, it's a memory intensive. And if you don't want to create a calculated columns, instead you want to create a measure. Okay, instead of creating a calculated column, you can create a measure. But the measure is right. It will not get stored in memory. It will not get stored in your. It will not get stored as part of the table. So whenever you invoke the measure, when you drag and drop the measure into a visual, that time it will get the calculations. The computation will be done on the fly. Okay, especially if the volume of the data is very high and if the business logic is a bit complex, in that time it'll become a CPU intensive one. So the measures is CPU intensive, whereas calculated column is memory intensive. Okay, and calculated tables, yes, obviously, right, you will have more than one columns in it. In the case of date dimension, so there are some project we have used a time dimension as well. Okay, and if they ask in the interview, what is date dimension? Did you use time dimension? You can tell them upfront, you have used only date dimension, time dimension, you have not used it. Okay, that is enough. And we can, in that kind of situation, you can go for calculated tables. And also in case of you want to perform any intermediate step, temporarily you want to store the data in a subset of the table. In that kind of situation also, we can go for calculated table. For example, you have a filter function. The filter function, what it does is, it returns a table. Let's say you wanted to filter a specific city, Ohio city, you wanted to filter it. In your data set, you have all these cities in USA related data is available, but you don't need all the data, but you want to filter only the Ohio state or city related data, right? So in that case, you are taking only the subset of the data. That data, you can store it temporarily in a calculator. In that kind of situation also, we can use it. So the key difference between these three types of classification, sorry, the calculations is in their context, okay? And the output they produce. You have something called row context and filter context. I'm not going to discuss that at this moment. We will discuss it little later, don't worry, okay? Next one is the commonly asked question is this one. So now we are going to discuss about DAX. DAX is also kind of a functional language, right? It's a functional language where here we are using the built-in functions. All we need to do is just, we should know the syntax. What is the, first argument, right? Which value to be passed to the first argument. For example, you have a calculate function. The first argument is supposed to be your expression. Second argument is filter 1. Third argument is your filter 2. Okay. So you know what values to be passed for, what values needs to be passed in which order to these functions. If you know that, that is more than sufficient. Fine. Then what is M language? M language. So M language, right? That one will get generated automatically as part of your Power Query editor. So all we do is just, if I wanted to replace some values, I want to replace some junk value with some valid value. So we do some replace. When you do the replace, what you do is in order to do the replace in Power Query editor, you just point and click on the specific column, and then you type the value which you want to replace it, or value which you want to find it, and then the next field you type the value that needs to be replaced. Behind the scene, the mashup engine, that is the driving force behind the Power Query editor. Okay, that is the one. What happens is the mashup engine in your Power Query editor, that is the one generates the M language. We have noticed several times, right? When you remove a column, behind the scene, in the formula bar, you would have seen table dot remove column. Inside the parenthesis, what are the column, right? It would mention. So behind the scene, the M language got created. So Power BI supports two languages. One is M language and DAX. You need to remember this one. M is a query formula language because in the Power Query editor we are using it, and it is called as a query formula language. DAX is an analytical data calculation language. These two are mutually exclusive. You cannot use M language in DAX and vice versa. Next one is the DAX engines. The DAX is powered by two internal engines. One is the formula engine, the other one is the storage engine. Okay, so now let us understand the mechanics of how the DAX formula is processed behind the scene by this DAX engine. Okay, the DAX formula is processed by, or the DAX query is processed by two engines. One is the formula engine, other one is the storage engine. For both import and direct query models, these two engines will come into picture. So understanding the understanding behind the curtain. All right. Let's say you have created a measure and you just dragged and dropped the measure in your visual. Fine. It displays the values once you drag and drop the measure into a visual. Fine. But behind the scene, behind the curtain, what is happening? Right. So it is always good understanding the underlying mechanism, right? How it processes your DAX queries behind the scene. It is always good understanding it's kind of an architecture. Okay. So in this case, now let us explore what is the role of formula engine and what is the role of storage engine. The formula engine is responsible for accepting the DAX query. For example, this is what your DAX query. So you have used your calculate function. The first argument is your expression. The expression is sum of sales. Okay, this is a measure. And next one is the filter. You are using some filter function. Here you want to find out the total sales for Chicago City. That is what this DAX query is going to return. Okay. So in this case, what happens is the formula engine, right? This DAX query, you have written it in your Power BI. Let's say this is a measure. This measure you created in Power BI. The moment when you drag and drop this measure into your visual, for example, here I just show you quickly. And here I have something called total sales. This is my measure. If I click on this, sum of sales, right? This is my measure. Total sales is my measure. And you cannot see the value as soon as you create a measure. Okay. The sum of total sales will get stored in your total sales. You cannot see the total sales, the value that got stored in your total sales. Instantly you cannot see it unless you drag and drop it in your visual. You cannot see it. So what is happening here is the moment when you drag and drop it, the formula engine, what it does is it accepts your DAX query, and then it processes your query and generates the query plan. So what do you mean by process the query? It checks, are there any syntax error is there? Okay, there are no syntax error. And then what it does is it generates a query plan. In the case of import connection mode, the formula engine, it sends a data request to your storage engine. This is called your storage engine. Because formula engine cannot retrieve the data directly from the data set. I'm talking about the import connectivity mode. Okay. In the case of import connectivity mode, what happens is the formula engine sends a query plan to your storage engine in order to get the data from the storage engine, because the formula engine cannot interact directly with or it cannot extract the data directly. Since what it does is it generates a query plan and then it sends it to your storage engine. In the storage engine, you have something called X velocity, and this is the one is responsible for retrieving the data and then send the data cache back to your formula engine. Hey, here is the data you requested. As per the query plan, I have generated the data. You pick up this data. So it will send the data cache to your formula engine. Now the question is, so what is this Vertipack and what is X velocity? In the past, they used to call this engine as a Vertipack engine. So now they renamed, Microsoft, they renamed the Vertipack engine as X velocity. What is this X velocity does? Why does the query plan in the case of import connectivity mode has to be sent to the Vertipack or the X velocity? What happens behind the scene here is the X velocity, upon receiving the query plan, it converts your tabular data into your columnar data, and then it encodes the data and then compresses the data, and then it loads it in memory. It is an in-memory columnar database. So what is columnar database? We will discuss it a little later. So what are the actions, what are the steps carried out by X velocity upon receiving the query plan from formula engine? So first thing is it will convert your tabular data into columnar database. And then the second step is it encodes your data. It encodes the data. And third step is it compresses the data. And then it loads the data into memory. The compressed data will get loaded in memory. Supposing your data file size, for example, you have an Excel file or CSV file, the Excel file size is 1 GB, 1 gigabyte. So what happens is the X velocity, it takes this data and then it converts this tabular data into columnar database. And then what happens is it encodes this data. What do you mean by encoding? We'll discuss this a little later, okay? And then what happens is it proceeds with compressing the data. So once it compresses, the size of this data will get reduced like anything. So 10 MB. 1 GB volume of the data got reduced to 10 MB. So this 10 MB, if you load it in memory, it will not consume too much of space, and also to store the 10 MB in your Power BI desktop, it will not consume much space, right? Storage space. Okay, and the compressed data is now 10 MB. The loading the 10 MB into your memory, it will not take much time, and at the same time, it will not consume too much of memory. And also, right, it is available in memory. It is also called as a cached data. That's why I mentioned a data cache here, right? The Vetipack, the Vexelacity, what it does is, it does these 4 steps, and then it returns the cached data to your formula engine. And then formula engine, it returns the output of this one to your visual. Let's say you have a chart here, right? Your column chart, you are using it. For this, it will return the output of this query here, right? This data cache will be received by formula engine, and this one will be sent to your this one, and the query it's nothing but the query is nothing but the query already dragged and dropped into your visual. The output of this one will be populated into your visual. Got it? So okay, in the case of direct query mode, this is import mode. So far we discussed about the import mode. In the case of import mode, the Xvelocity engine gets kicked in. In the case of direct connectivity mode, direct query mode, what happens is the formula engine still receives or accepts the DAX query, and then it processes the DAX query, and then it generates the query plan. This query plan will be sent directly to your SQL server. Let's say here you have SQL server. Look here on the right side, you have the SQL server, and the query plan will get executed in your SQL server, and then the SQL server will send the data back, the query's output back to your formula engine, and then the formula engine will send the result of your SQL, the SQL query, and then the data, the visual will get populated. Got it? So it reads the data source and transforms the data into columnar structure and encodes and compresses data within each of the columns in the case of import mode, which one the Xvelocity is responsible for that. And then it establishes the dictionary and index for each of the columns. That we will see it little later. And if you work with the direct query, what is happening? You cannot use Vertipack or the Xvelocity. It is not going to use Xvelocity. In the case of direct query, the Xvelocity engine, storage engine can only be used for imported models using the import function. Okay. In the case of direct query, it will be directly sent to your SQL query, SQL server, and then the query will get executed on your SQL server, and the output will be sent back from your SQL server to your formula engine, and then the formula engine will send the data, it will populate the data into your visual. So now the question is, okay, it converts the Xvelocity, convert the tabular data into columnar data. So what do you mean by columnar data? Why the Xvelocity has to convert the tabular data into columnar data? Okay, so what are the examples for columnar database? Any idea? Anybody has any idea about the columnar database? Columnar databases are like Cassandra, HBase, and Vertica. These are called as columnar databases. Columnar databases are very much popular nowadays in the case of Hadoop environment, the big data environment. Okay, with the columnar databases, the column access is fast and effective. Look here, now let us understand what is row store and column store. Our Xvelocity engine, it converts your tabular data, which is nothing but the row store data, into columnar data. In the case of columnar data, what happens is it stores each column separately. Okay, what is the big deal? Storing the column separately, what is going to happen? So the idea of storing the columns separately is, supposing you wanted to, let's say you have 100 columns are there in your data set. As per your DAX query, right? It requires only these 2 columns, name and unit price. Within this, you want to retrieve only these 2 records, subset of these data. So in that case, your DAX query will hit only these 2 columns. But here also, we have the same column. So here, for example, you have the name and the same unit price is there. But here also it can go, can't it go and get no. What will happen is, in the case of row store, it goes to the first column and checks whether the first column is a name or not. No, it is not a name, it is a date. Okay, it skips and then it goes to the next column. Until it finds the name column, it has to skip the columns. Until it finds the unit price, right? It needs to skip the columns. In the case of huge volume of data, skipping will take longer time. Hence, what they did, the architects, right? The architects, what they did, they came up with a strategy of storing the data separately, so that whichever columns that you are interested, it will go and directly hit those columns and then it will fetch. Here in this case, there is no skipping. It is not going to search each and every column. It goes and is. This is what the columnar. Hope you understood. The columnar databases are much more efficient in this case, right? And the next step is, what is the next step we discussed? First, it converts your tabular data into columnar data. Now you understood the advantage of columnar data and why it converts the tabular data into columnar. You understood. And the next one is encoding and then compressing the data. So before compressing it, it encodes the data. In order to reduce the size of your data, it does some kind of encoding. You have something called value encoding, run length encoding, and hash encoding. Okay, and then so by doing the encoding, it reduces the size of your data, and then it compresses the data. First, it reduces the data. So when you reduce the data using the encoding technique, itself the data volume, the storage will get reduced. On top, it does the compressing, and then it load the compressed data into memory. Hence, the performance is much faster because of the X velocity. Okay. So now let us continue with understanding what is the encoding. What are the different types of encodings are available? We have something called value encoding, and the next one is the dictionary encoding. Dictionary encoding is also called as hash encoding. Next one is run length encoding. It is very simple to understand. Let us start with understanding what exactly value encoding in DAX. Okay. This value encoding is used on integer values only. So you have sales column, you have quantity column, and you have profit. So these are your integer, or these not the sales. I meant about the quantity. Okay, quantity. The integer values column. Okay, what happens is the value encoding, it works on integer values, especially since the X velocity converts a lot of values in Power BI to integers. Okay, so how the value encoding does is very interesting one. Look here, of these values, which one is minimum value? 194. This is a very minimum value. It first find the minimum value and then it subtract the minimum value from each and every value. So 212 minus 194 is your 18, and 197 minus 194 is 3. So likewise, 194 minus 194 is 0. Right? After subtracting the minimum value from each and every value, now we can see that it got the 3 digits got reduced to 2 digits. Okay, in this case, the Vertipack discovered these values by subtracting the minimum value from all the values of the column, and it could modify the range of the column now, right? It reduced it. It reduced this into a range from 0 to 22. Okay, 0 to 22. Okay, storing numbers up to 22 requires less bits. It requires just 5 bits, whereas in this case, 8 bits are required. You might be asking this question, just we are saving 3 bits only, right? So, just to save 3 bits, why do we need to do, why do we need to complicate by doing value encoding? So in this case, we are just looking at oddly few numbers here, right? Few data points. But when we are dealing with 25 million records or 50 million, 100 million records, 100 million into 3 bits is a big number. So it by doing encoding, it reduces the range of your data. Reduce the range of your values in your columns. Okay, and the next one is the hash encoding. the hash encoding behind the scene, right? How it works is it builds a dictionary in this case. For example, you have a text data, right? In the case of text data, the hash coding encoding is done. See, initially we discussed about value encoding. Value encoding is meant for integer values. In the case of text, the hash encoding technique is used. So what happens is behind the scene, it builds that dictionary, the X velocity, okay? And then the dictionary will contain the distinct values of the column. So this is my column called color. There is a column called color. In this you have red, white, black. And this is my dictionary, okay? It builds a dictionary here. In the case of hash encoding. So in the dictionary, what happens is the dictionary contains the distinct values of the columns. What is the distinct value? It excludes the duplicates. Red will appear only one time. By excluding the duplicate values, in this case, white occurs only one time, okay, white, whereas black occurs more than one time. It excludes the duplicate and it takes only the distinct value, and similarly blue. Now for each distinct value, it assigns the ID here. Okay, and in this case, what happened? It replaces the color with this index value. So wherever red is there, it replaces it by 0. Look here, the second value also red, it replaces it by 0, and white, it replaces it with 1, and black, for black, it replaces it with 2, and so on. Now, if you see your original column, the size got reduced like anything. On top, if the X velocity engine does the compression, the size will be very, very less. The next one is the run length encoding. It is used to look for the repeating values. Okay, it codes a column that is value encoded or dictionary encoded. This is this uses kind of the hybrid of both dictionary encoding as well as the run length encoding. So in this case, what happens is so this is my column quoter. In this case, how many number of occurrences are there for Q1? 310 times the Q1 value got repeated, and then the Q2 value got repeated 290 times. So what happens is it creates that run length encoding. So it transforms this data into RLE for encoded thing like this. So Q1, so it will create something like that. In the quarter is Q1, and where it starts with 1 and ends with, and then how many number of occurrences are the 310. And then Q2, it starts from 311th position. 311 from 311th position to how many number of occurrences are there from 311th position. 290 occurrences are there. This is starting, and this is the count, and the start from this one, right? So that is how it transforms this original data into like this. And again, here it uses the dictionary encoding. So in this case, what happens is for the Q1, Q2, Q3, Q4, what happens is it assigns an index. It takes the distinct values of Q1, Q2, Q3, 4, and then it assigns the index value. So now what happens is in this case, instead of quarter value, it replaces the quarter by, look here, in this case Q1, Q1, right? So look here, in this case, yeah. So this is what is happening. 0, okay, sorry. In this case, 0, 1, 2, 3, and then the Q1, Q2, Q3. In the case of Q1, how many number of occurrences are there? Q2, how many number of occurrences are there? And Q3, how many number of occurrences? And Q4, how many number of? And then finally, it uses this ID only, index value only here to replace your original value here. So Q1 is what is a Q1? Q1 is 0 here, and then 0 has 310 occurrences, right? 0, 0, 0, 0. And Q2 is 1 here. The index value is 1 here. Wherever Q2 is there, it puts 1 here. Right, so this is how it does the encoding for your values in the original column, right? So that the range of values in your transformed column is going to be very less. And then the X velocity, the next step, what it does is it proceeds with compressing these data. For text data, it uses which encoding? Hash encoding. And for integer, it uses the value encoding, and the next one is run length encoding. In the case of repeated values, right, and those kind of situation, it uses something called run length encoding. Got it? So, this is the idea behind, compressing the data. Okay. And after the applying the encoding, right, the size will get reduced. Okay. This is the technique used to compress the data. To summarize, DAX uses two engines, the formula engine and the storage engine. The formula engine interprets and evaluates DAX. That's it. It cannot go and retrieve the data from your data file. In the case of import mode, it relies on the storage engine. Okay. And the storage engine, what it does is it compresses and encodes the data. They will ask you this one. So what is the role of formula engine? What is storage engine? Formula engine, simply it takes the information and then takes the query and then interpret it, and then it evaluates, generate the query plan. That's all. It cannot access the data directly. Which one? Formula engine. And the next thing is, it's something like cook in your house, right? So only the cook can have access to the food, and you are asking her, hey, these are the things I needed. The cook will serve you, right? So that is the thing. Okay, formula engine is something like the person. Okay, and then the storage is something like a cook. Okay, so this simple analogy. Okay, so this is how it works. The storage engine, importantly, it compresses and encodes the data in the case of import connectivity mode. So there are two types of storage engines. One is the X velocity, other one is direct query. The storage engine itself, there are two types of storage engine is there. One is X velocity and direct query. In the case of direct query, even in the case of direct query mode, the formula engine interprets and evaluates for DAX query, and then it sends the request directly to your RDBMS server. Let's say, for example, SQL server you are using it. The query plan will be sent directly to your SQL server. It is not doing any compressing all the things. Okay, the query will be fired on your SQL server. The output of the SQL query will be sent back to your formula engine. The formula engine in turn passes the data to your visual. Supposing you have used that measure in your visual, it will get populated there. Say the X velocity is used for in-memory storage, and the direct connectivity mode is used for direct connection to external sources. So they both create data caches and then and send them to formula engine for DAX query evaluation. You need to remember this. Next one is Vertipack stores data using columnar database setup. That is what we already discussed, and the raw data is compressed and encoded to optimize processing and to reduce the storage space. Okay. Hope you are able to understand the what are the mechanics behind how this Vertipack or the X velocity engine works, right, behind the scene, which is nothing but the DAX engines.